Let's take a look at the molecular geometry for CH3OH, that's methanol. So we start with our Lewis structure. That shows how the electrons in the atoms are arranged around the atoms. We'll focus first on the carbon, and then we'll look at the oxygen. So for the central carbon here, we have 1, 2, 3, 4 different things attached to it. This OH here, that's what makes methanol an alcohol. So 4 things attached to the central carbon. That gives us a steric number of 4. So if we look at the steric number, again, that's the number of things attached to the central atom we're interested in. Steric number of 4, and there are no lone pairs. All the electrons around the carbon, they're involved in chemical bonds. We have a tetrahedral molecular geometry, and the angle's about 109.5. Let's take a look at how that might happen. So we can use VSEPR theory to predict what the shape will look like based on the Lewis structure. We have that carbon there, and we have 4 things around it. So as we add the 4 things to it, they spread out. So here's 2 hydrogen atoms, for example. They spread way out. We add another one. They spread out again. And finally, we add that OH group, and you can see that we have a tetrahedral molecular geometry. All these hydrogens and the OH group, they're spread out, pushing each other away to give us a bond angle about 109.5. It'll be a little different because we have that OH group there, but it should be right about 109.5. Let's go back to our Lewis structure. If we're looking at the oxygen here, and we want to know the molecular geometry of the oxygen in CH3OH in methanol, we can look at our table again. We have 1, 2, 3, 4 things attached to the oxygen. So we count the lone pairs. We have 4 things, and we have 1, 2 lone pairs. So 4 with 2 lone pairs. That's called a bent molecular geometry. And it has an angle right here of about 109.5. Let's look again back at our model. So we'll add our 2 lone pairs, and they would spread out, push each other away. And then we'll add the hydrogen, and finally the rest of the molecule. And you can see that we do have that bent molecular geometry. There it is, where those 2 lone pairs are pushing the hydrogens down to give us about 109.5 degrees. So for the oxygen, we're talking about a bent molecular geometry with a bond angle of about 109.5. Let's take a look at the entire molecule right now to wrap up. So here's the methanol molecule. We have our carbon, the whites are the hydrogens and the reds are the oxygen. And we should draw some lone pairs here in on our oxygen because we see that there's 2 lone pairs. And those would be right above the oxygen atom. Let's put a pair right here, kind of behind this oxygen, and then put the other pair here, kind of in front of the oxygen. So this is our bent molecular geometry on the oxygen, and then we have the tetrahedral molecular geometry on the carbon. This is Dr. B with the molecular geometry or shape for CH3OH methanol, and thanks for watching.